So it's a good question. The Sayed has asked that. So brief explanation about the chopper. So basically, we know what we mean by rectifier, which will simply convert your AC to pulsating DC. In a similar way, we have the chopper here. It will convert DC voltage to the variable DC. Very simple. So here you can see fixed DC voltage we are applying as input. So the block is, it is written as inverter here. It is converting DC to AC. And again the rectifier is there. Its main duty is to convert AC to pulsating DC. So this is how you can see the chopper is going to look here. It is going to perform the function of two things here, the inverter and then the rectifier. It doesn't mean that it is doing DC to AC and then AC to pulsating DC. Its a circuit will be quite different that we have already learned there. Its simple duty is to convert DC to the pulsating DC. So why it is exactly required is that we already know that the rectifier is there which is doing this work converting AC. You can see the frequency is there. AC signal means frequency will be there. That will be converted to the pulsating DC having almost zero frequency. But in some cases where AC is AC will not be there, but DC supply will be there. From that we want a pulsating DC output. For example, here you can see the battery operated vehicles, subway cars and trolley buses where variable DC is required from the DC voltage. These are also known as line commutated converters because their turning off is automatically done whenever the line voltage, that is sinusoidal voltage, will cross the zero. So whenever the voltage will cross the zero, will become zero, automatically the thyristors which are used as a switching elements in these choppers will be turned on. So that's why these are also called as line commutated converters. And here it is just simply shown that it is similar to the functioning of the combined function of the inverter and the rectifier diode. That's all.
Sir, excuse,
Yes.
sir, what is the difference between variable DC and fixed DC?
Fixed DC voltage means here there is no any amplitude variation. That is an ideal case. Amplitude variation ಇರೋದಿಲ್ಲ, zero frequency ಇರ್ತದೆ. That is an ideal case. Pulsating DC means slight amplitude variation and slight frequency deviation will be there. That is very negligible, but very small. Is it clear?
Ah, sir, yes.
So let us complete this the classification. So DC chopper, just now yes, once again we are going to explain here. Constant DC is converted to the variable DC. You can see this is the symbol we are using, the rectangular symbol. Inside that the switch has been shown. So this is the symbol we are using to represent the chopper connected to the load. That is going to give the desired variable DC from the supplied DC. So solid state choppers are normally used, commonly used in the trolley cars, battery operated vehicles, induction motors, marine haulers. So its main features or advantages, it saves the power, better efficiency, fast response. The switching will not encounter more delayed operation. Low maintenance choppers will not require more maintenance here. Reduced size, compacting the size, and the smooth control is there. So these are the main features for the DC chopper. So they are called by synonymously. They are called chopper is also known as a DC chopper or line commutated chopper. Remember these things. So whenever in examination, if you get something like instead of what you mean by line commutated chopper or DC chopper or chopper, all are same. If you they will ask you to give the classification of a line commutated chopper means the same thing, the same classification. You have to explain like this one here. So once again, we will begin with the discussion of chopper classification here. The first one, the based on the levels, voltage levels at the input and output side. What is the input to the chopper? It is a fixed DC. Its amplitude will be fixed, frequency will be fixed. That is 0 hertz. Output we are expecting desired amplitude and desired slight frequency for our DC. That is a pulsating DC. So this is that's why this based on the input output voltage levels we got two different types of choppers. Step up chopper. Step up means the voltage level of the pulsating DC at the output of chopper is little bit higher than the voltage level at the input DC of the chopper. That's what is known as step up. Means output of the chopper is a little bit higher than the input level of the input to the chopper. In a similar way, we can explain about the step down chopper, where the output of the chopper, that is a pulsating DC level, is a little bit lower than that of the input DC voltage that is applied as input to the chopper. So based on that, we are going to classify this as input based on step up or step down chopper. Next one, based on the directions of the output voltage and current. Hello.
Yes, sir.
So based on the direction of output voltage and current, we got many variations of the choppers are there. Whereas the first one we are going to call it as a class A chopper or a type A chopper. So here it has been shown by the arrow mark. It is indicating that the operation of this type A chopper or class A chopper is characterized or described by this simple graph. This graph will indicate output voltage E naught versus output current I naught. The hashed portion, it will indicate that we are able to get both the output voltage and current, output current positive. Means both will lie in the first quadrant. Means because both are positive, which will representing the whole operation of type A or class A chopper is going to reside in the first quadrant. So like that, guys, you need to explain in your own words. In the similar manner, if you see the operational graph or CAD6 of the type B or class B chopper, where you can see again the output voltage will be fixed as positive only, but the output current is going to be negative. Understanding this one? Even though the input current may be positive, but the output current is going to be negative. This will indicate out of phase, you can say. Okay. So the input current is on the another side, output current you can see on the another opposite side of the axis, this y axis. Type A, type B, both are same where the output voltage is fixed, that is positive only, but the output current is going to be different. That is the main difference between type A and type B chopper. If you look at type C, it will appear something like it is a combination of type A and type B. Again, the output voltage is fixed at positive only. It is not going to be negative here. But we are able to get both the versions. From the type C chopper, we are able to get either type A or type B chopper versions. In a similar way, the type B, here you can see the output voltage got its negative version here. The previous three cases, the output voltage is going to be positive, but we shifted only the polarity of the output current. So based on that, we got type A, output current is positive. Type B, the output current is negative. Type B, the output current is negative. Type C, the output current may be positive or negative. Now you can see in type C, output current is positive, that is fixed, but the output voltage may be positive or negative. Both the versions we are able to get. Now you can see the type P chopper, we are able to get, it is something like a universal chopper. Okay, we can also simply, roughly we can call it as universal chopper, which is going to combine all the operations of the previous two or four types of the choppers. So this is how, guys, we are able to explain or going to classify the chopper based on the directions of the output voltage and current. Next one, according to the circuit operation, first quadrant chopper or type A chopper. So that is the type A chopper. First quadrant chopper means the choppers which are going to describe, we are going to describe their operation contained in limited to only one quadrant. First quadrant choppers means both type A and type B are coming. Sorry, type A chopper is coming because it is residing in the first quadrant only. Two quadrant. Two quadrant chopper means so two quadrants where the choppers operation is limited to the two quadrants. Type C is coming here and type D is also coming. Next four quadrant chopper means type E chopper is coming. Now based on the computation methods means based on how the switching elements that is the SCRs used in the choppers will be turned off. Based on that, suppose if you are using voltage as a main responsible person to turn off the SCRs or thyristors used as switching elements in the chopper, then it is known as a voltage commutated chopper. Means you are using voltage as a main source to turn off the switching elements used in the chopper. Indirectly, you are going to turn off the chopper by using the voltage. That's why it is known as a voltage commutated chopper. Similarly, if current is going to be the responsible person or reason, a biasing reason, to turn off the thyristors used as switching elements in the chopper, then it is known as a current commutated chopper. In the similar way, load commutated chopper means we'll be having one load in any chopper. Across that, we are going to measure voltage or current. If that load voltage or the current flowing through that load is going to cause the turning off of the switching elements like thyristors used in the chopper, then it is known as a load commutated chopper. In other words, load is indirectly controlling the commutation of the thyristors used as switching elements in the chopper. A big sentence, but it is a very important sentence. Impulse commutated chopper. In this case, we are using a train of pulses to turn off the thyristors used as switching elements in the chopper. Like that, based on the input-output voltage levels, we got step up or step down chopper. Based on the direction of output voltage and current, we got class A, class B, class C, class D, class C chopper. Based on the quadrants, we got 1, 2 or 4 quadrant choppers. Based on the computation technique, we got either voltage controlled, that is voltage commutated, current controlled or current commutated, load controlled or load commutated, impulse controlled or impulse commutated choppers. In a similar fashion, we have also discussed in detail in the previous slides there about the step down chopper, how it is going to behave, step down chopper. Some very little derivations you will be getting here. So I want you to remember these things quite frequently used in solving the problems here. It's like that. So this all about the chopper what he has asked.
Excuse me,
Any yes, yes.
sir. Could you explain briefly about step down chopper?
What is the specific thing you want there? Step
This
down,
one is.
I will tell. Figure A shows a typical circuit diagram, basic circuit diagram for the step down chopper, and figure will show step down chopper with a transistor as a switch. The switching element we have barely shown here, roughly shown here. This switching element could be anything. It may be diode, it may be transistor, it may be power transistor, it may be thyristor, it could be anything. So now we are using as an example as a transistor as a switch here. Now the source is applied between the base and this, you can see the collector. And between the base and emitter, we are connecting the load that is R. Across that, we are taking the output voltage V0 and output current I0 is flowing. Input current Is is flowing to the collector and base drive, base emitter junction forward biased, collector base, emitter base junction forward biased, collector base junction reverse biased. So this is the normal biasing conditions for the transistor to operate in the Q mode. This already you will know it. Now coming to the step down here. So let us look at the waveform to understand this one. The operation is very simple. We are applying the Vs, you can see here. It will consist of this rectangular pulse, subsequent shapes here with the T on and T off, a subsequent on and off periods. Vs here, Vs I denoted here. Off period I will be considering it as a very small delta T, and on period is a little bit large, very larger than the T off. If you combine these two, you will get the total time period T. Okay. Now let us see here. So when you turn on the switch T on, during T on what will happen? When switch is on, this one is short circuited, then the IS current will start flowing through the circuit, and that will increase the current exponentially. It will increase the current exponentially, and output voltage, because of the current flowing through the R, will be getting the output voltage that is fixed during T on. Now at the end of T on, transistor will be turned off. That is for a short duration, and current will decrease and voltage will also decrease. Voltage will become zero. Okay. With the resistive load, what we are seeing here. So therefore, you can see output voltage is decreased, shown by the dotted line here. Here you can see output voltage got decreased compared to the input what you are applying here. That has been shown very much clearly in the derivation here. So you can see how it has been decreased. That will be very much clear. The relationship between the output and input, output V naught and input Vs. So output we are getting by multiplying something to the Vs. Okay. And that will depend on the dou value that is lying between 0 to 1. If you multiply Vs by any value between 0 to 1, let us assume that the Vs is 5 volt. And if you multiply that 5 volt with any fraction number lying between 0 to 1, you will be getting less than 5 volt only. Output we are getting less than 5 volt. That is because we are getting V naught equal to some fraction multiplied with Vs. Fraction times Vs. Dou times Vs. Okay. So dou is lying between 0 to 1 for the step down chopper. So because this dou delta T is very much small. So that itself is going to, you can see, will making you to get the output voltage less than the input. That's why it is known as the step down chopper with the resistive load. Is it clear? So like that you can describe about step up chopper also. In step up chopper we are going to include this cell di by dt also. That is
Sir,
going to add here. So that's why it is going to enhance the output voltage compared to the input.
sir, in
That's what
step
is
up,
going to be step down chopper. Yes.
excuse me, sir, in step up chopper there is diode, no sir?
Diode is there along with the inductor we have kept. No. Inductor is going to store the voltage for some time. That will be added with the Vs. In the previous case, no inductance was there and no additional voltage will be added with Vs in series. Now we are adding that stored voltage in the inductance along with in series with the Vs, and thereby we are going to enhance the output compared to the input. Input ಬರೀ Vs ಅಷ್ಟೇ ಇರ್ತದೆ. ಔಟ್ಪುಟ್ ನಿಮ್ದು ಏನು ಬರ್ತೈತೆ Vs plus inductance voltage. That is L into di not by dt. Is it clear? So
Yes.
that's what is a step up. Output voltage is enhanced by an amount of L di not by dt compared to input Vs. Your input is only Vs. Your output is Vs plus L di not by or ds by dt, whatever. In order to combine ಮಾಡಿದ್ರೆ you will get a step up down chopper like this. You are combining this one just by simply controlling the dou value. Yes, anybody has any doubts or anyone? You are free to ask anything. Don't hesitate. You can also feel happy to explain, present the things. I have all the slides, not to worry. Even actually like to keep the whole session today. Your doubts only. Even I will also request the slow learners. So yesterday You not attended the class. Slow learners are there that I mentioned the names there in the group there. Anybody is there? Slow learners. Do you have any doubts? Because as I am saying that you are unable to attend the special classes there, I have recorded that also. So today at least you are present in this today's regular class. So let me see who are there.
Sir, I'm also there.
Just now, Sayed, you only asked.
Ah,
Yeah, yeah, it's a good question. You are reading
sir,
regularly?
not, not sir.
Now we are going to face the second CA. But still time is there, you do well.
Ah,
And
sir,
if you will get any doubts,
sir,
you can also use the WhatsApp group there.
sir, we can ask the question from module one also, sir.
Yeah, yeah.
Sir, about gate trigger circuit, I'm not getting, sir. Gate trigger.
1 minute, 1 minute. That will take up after some time because now the second CI is coming no ahead.
Ah, ah,
So
sir, okay, sir.
because everybody is expecting that one. Okay, if your doubt is very much specific, I can take that one.
Okay, sir.
What is your doubt?
Sir, about gate trigger circuit.
Yeah, what do you want there?
So prior to that, that is gate characteristics of a SCR, no, sir.
Hmm. Yeah,
Previous. After that, yeah, in that firing circuit, resistive firing circuit, I'm not unable to follow that, sir.
let me see the slides and tell me. Gate characteristics. Let me check.
Ah, sir, this one.
Gate trigger circuit.
Ah, sir, this one.
This one. Which one you want?
This one. Previous to this.
This one. Okay. So we are not going in deep about the operation of this circuit. Briefly, you have to explain. You have to draw the block diagram, and you have to explain the things here. Whatever the things are visible. So for this one, the main blocks what you need to explain here is gate trigger circuit is there. The block diagram has been shown here. Let me show this. So gate triggering circuit. So what actually he is presenting here is that this is the block which is going to take care of turning on of the each of the thyristors which have been shown here. Four thyristors are there as it is visible T1, T2, T3 and T4, and each of the thyristor has got a gate terminal and they will be turned on by applying appropriate gate pulses. So when we have to apply, you can show here, it has been the control of thyristors T1, T2. So during this control voltage, they will be turned on, and control of thyristors T3 and T4 during this control voltage means at every such control voltage, this is nothing but a ramp voltage. It has been written a ramp. Control voltage, they are using it as a ramp voltage. At every subsequent ramp voltage, a pair of thyristors will be turned. This is a bridge circuit fashion they have connected here. So with this whole block, here what main logic is that we are trying to learn how to turn on a pair of thyristors at subsequent ramp voltages. That's all. Now for that we need ramp voltage. So we need to have the ramp voltage here. So for that one, so the pulse amplifier is there here. So that is going to look at the generation of such kind of ramp pulses. So these ramp pulses we can see here will be given to the gate terminal. So that circuitry is not given in detail. With the help of the all the four thyristors, you can see T4 is there, T1 has been shown here. This is the G3 means T3 will be there, and here G2 means G2 will be there. All four thyristors will be interconnected through their secondary windings to this pulse amplifier primary, and by that they are going to get their subsequent gate triggerings. When T1, T2 will be triggered and when T3, T4 will be triggered. So this pulse amplifier will see that the pulses will be applied to the subsequent gate terminals of the T1, T2 or T3, T4. T1, T2 or T3, T4. But when they will be given, that is controlled by this control logic ground. You are observing no here. Are you getting? So this is how guys you have to start explaining about this. We'll start from here. ಇಲ್ಲಿ ಮೇನ್ ಐಡಿಯಾ ಏನೈತೆ ಅಂದ್ರೆ ವಾಟ್ ವಿ ಆರ್ ಲರ್ನಿಂಗ್ ವಿ ಆರ್ ಟ್ರೈಂಗ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹೌ ದ ಗೇಟ್ ಟ್ರಿಗರಿಂಗ್ ಸಪ್ಲೈ ಅವು ಪಲ್ಸಸ್ ಹ್ಯಾಂಗೆ ಕೊಡ್ತೀವಿ ನಾವು ಎಲ್ಲ ಈಗ 4 ಥೆರಿಸ್ಟರ್ಸ್ ಅದಾವ ಸುಮ್ಮನೆ ರ್ಯಾಂಡಮ್ ಆಗಿ ಏನೋ ಒಂದು ಎಲ್ಲ ಗೇಟ್ ಟರ್ಮಿನಲ್ಗೆ T1 ಏನೋ ಕೊಟ್ಟು T2 ಕೊಟ್ಟಿವಿ ಆಮೇಲೆ T4 T3 ಏನೋ ರ್ಯಾಂಡಮ್ ಫ್ಯಾಷನ್ ಒಳಗೆ ಏನೋ ಆಗ್ತಿರಂಗಿಲ್ಲ. ಓಕೆ, so this control voltage what you are getting no the ramp voltage, that is series of pulses will be generated by this pulse amplifier. ಈ pulse amplifier ಗೆ ಇದ್ರ primary ಇಲ್ಲಿ ಅಂತ secondary couple ಆಗ್ತಿರ್ತಾವ gate pulses, where all 4 thyristors will be individually connected through their secondary windings like this. You can see 1:1 1:1 transformer ಕೊಟ್ಟಾರೆ. So this is how the pulse amplifier is going to take care of that. Pulses will be applied to the particular pair of thyristors, but at what time? That will be decided by this control logic ground, input control voltage. Adon input control voltage ಬೇರೆನೇ ಇರುತ್ತೆ. Okay, with the delay angle block, they will decide that one. That is also you can see one of the input is there. So this delay angle block and input control voltage will be decided by this another block. You can see if you go above transformer line voltage line voltage ಇಲ್ಲಿ ಇರ್ತೈತೆ. So that is coupled to the secondary ಒಳಗೆ ಎರಡು diodes ಅದಾವ with the DC power supply for the gate trigger circuit. So these two diodes are turning on turning off zero crossing detection ಮಾಡ್ತಾವ. So how they are doing zero crossing detection, that we are not going in deep about that. So whenever, just briefly I will tell, whenever the transformer line voltage will cross the zero, okay, so whenever the transformer line voltage cross the zero, that will be detected by this block. Okay, because why we want zero crossing detection, to identify ಇಲ್ಲಿಂದ ಪಾಸಿಟಿವ್ ಒಳಗಿತ್ತು ನಿಮ್ದು ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಲೈನ್ ವೋಲ್ಟೇಜ್, ಇದು ಜೀರೋ ಕ್ರಾಸಿಂಗ್ ಆದ್ಮೇಲೆ ನೆಗೆಟಿವ್ ಒಳಗೆ ಹೋಯ್ತು, ಆಮೇಲೆ ಮತ್ತೆ ಪಾಸಿಟಿವ್ ಒಳಗೆ ಬರ್ತದೆ. ಟು ಐಡೆಂಟಿಫೈ ದಿಸ್ ಪಾಸಿಟಿವ್ ಅಂಡ್ ನೆಗೆಟಿವ್. Okay, during positive peak we are going to turn on one pair of thyristors T1 and T2. During negative peak we want to turn on the T3 T4. How will identify that positive peak reach agate negative peak reach agate? For that we identify the zero crossing diffraction to subsequently to identify whether we are in the positive peak or negative peak, negative region. Then subsequently we are going to turn on the T1 T2. Means when we are in the positive peak, our circuit will come to know that now a pulse amplifier will come to know that I need to apply the pulses to the gate terminals of T1 T2. When I am in the negative peak, then pulse amplifier will come to know that I need to apply the pulses to the gate terminals of T3 T4 like that. So this is how guys you have to explain in your own words. This is all about a very rough explanation about the gate trigger circuit, how it is going to function. We are not going in deep. So that's why this diagram separately I have shown here. Taking the help of the bridge circuit formed by the 4 thyristors and this waveform, we are trying to explain how a pair of T1 and T2, T3, T4 and when they will be triggered. If we add a question, you answer ಮಾಡಬೇಕು. How they will be triggered in pair T1, T2, ಮೇಲಿನ T3, T4, ಕೆಳಗಿನ and when. How means pulse amplifier and when means these blocks. Is it clear? That is a very good question. Yes, anybody else? There's the module 1 related to CI2 syllabus. Anybody want to ask? That is Sayer or anybody else. This is the module 4. Let me see that. Okay, anybody want to ask anything? You can ask anything. No. All modules are there here. Module 1, 2, 3.
Excuse me,
Yes. What is
sir.
this one?
Can you explain about the single phase full wave control midpoint rectifier?
What is your good name?
Sri Gauri.
What is what is your good name?
Sri Gauri.
Pardon? Can you repeat me the question?
Single phase full wave control midpoint rectifier.
Single phase control. Where will get this? Can you please help me here? Model 3 and
Yes, sir. Model 3.
just say the slide and tell me the
Sir, no, sir. Model 2.
model. Let me go there. So model 2 is here. Single phase full wave control. Yeah. So this one. So this one is single phase full wave control. Just I will briefly explain its operation here. We are applying the AC input here equal to EM sin omega t to the primary of the transformer. So dots you can see placed symmetrically on either side of the transformer, that is primary and secondary. That itself will indicate that we are using 1:1 transformer. But on the secondary you can see that we are using the midpoint, the load is connected at the midpoint. So because of that, if one is on, another one will be off. Now when we apply the AC input EM sin omega t, now firing angle will be applied at some firing angle. Let's assume that alpha equal to acute angle 30 degree, 30 degree. So now in example hingu kelbodu. Explain the operation of single phase full bridge circuit at a firing angle of 30 degree or 45 degree like that. So I think that also I have shown here. Now before applying the firing pulse at alpha, before that your input is increasing. T1 will be on, T2 will be off, but T1 is in the forward blocking state unless you apply the gate triggering pulse and it will be shifted to the conduction state. That will happen only when you apply the firing angle at alpha. Means up to this one, load voltage will be zero because T1 will be off. Load current is zero. So all the voltage will appear across T1, T1 and T2, both are on. But when you apply the firing angle at alpha, that will make your T1 to on. Current will start flowing as it has been shown in the circuit diagram. The anti-clockwise direction, that is from right to left. A T1 R N. So this much voltage will appear across the load. Similarly, the current will follow the voltage, but voltage across T1 will be negligible. Practically, it is very small. So this will continue until it will reach the zero. When it will cross the zero. Okay. When it will cross the zero, natural commutation, automatically T1 will be off. When T1 is off, at pi to this until we apply the next triggering pulse. Next triggering pulse here. So pi to this next triggering pulse apply ಮಾಡು ಏನು duration ಇದೆಯಲ್ಲ, between this period both are of no load voltage, no load current. Again, the output voltage, all the voltage will appear across T1 and T2. You will add to half your power. When again you apply the triggering pulse, that will trigger your T2. Output voltage and current will appear across the load. Because of the T2 is conducting like this, the current is flowing in the clockwise direction. Voltage across the T2 is negligible. Again, this situation will continue until you will apply the next triggering pulse. Is it clear? This is how the cycle will repeat and complete the operation. Is it clear?
Yes, sir. It's clear.
Yes. So main thing I want to suggest here all of you, you have to focus on the derivations. Normally derivation ಕೇಳಿರ್ತಾರೆ, DC voltage, average DC voltage, RMS voltage derivation. Already it is there provided with the notes there. You practice those derivations, and also end equations are going to be quite useful in solving the numericals. So quite diversified doubts we are getting. So this is one thing from where we are going to start our syllabus for your second CI, single phase full with R and RL. Yes, any other questions? Only 2 members have asked out of 45. Don't hesitate, let it be silly, you can ask any question. Anything you have felt very difficult so far, what we have covered? Very, very difficult. I am not at all understanding like that. Nothing. Any further questions?
Hello, sir.
Yeah.
We are about to flyback converter discontinuous mode, sir.
I have to repeat that.
Yes, sir.
Let me go to slide. So this one you want?
Yes, sir. This one.
Flyback converter. Discontinuous mode. Okay. So briefly we'll try to understand this isolated flyback converter discontinuous mode. First word you can say isolated. We are using transformer, and it is quoted that it is a high frequency Faraday core transformer we are using. So one thing we have to understand, whenever we are using transformer, it is going to provide an isolation between the circuit parts operating on its primary and secondary sides. Isolation means they are both protected from any kind of short circuits. Their operations are happening parallelly and independently. They may be having influence, coupling of voltage or current, but their operations are independently happening That is how it is. The transformer is going to provide isolation between the input and output parts. And another important feature why we are using Farad core. That's what is called isolated. Okay. So the important feature of this Farad core, the material what they are using in the making of this transformer. If you look at the dots which have been placed there in the diagram, important feature of this Farad core high frequency transformer is that whenever the primary current is flowing, secondary current is not there. When primary current is not flowing, secondary current is flowing. It doesn't mean that it is discontinuous mode. Discontinuous mode is ಮುಂದೆ ಬರ್ತದೆ. We are trying to understand isolated transformer. This transformer has got two important properties. One thing, it is going to see that both primary and secondary circuit parts will be totally isolated. And second important property is that when primary current is flowing, secondary current is not flowing. Remember this. And when primary current is not flowing, secondary current is flowing. This is the main property of transformer. Now let us continue the operation. The circuit diagram I have shown here below that you can understand it easily. These are the waveforms. VQ, it will indicate the voltage across the transistor. IP, the primary current. IS, the secondary current. Pi, it will indicate the phase amount of charge. Let us start with application of DC supply here. EDC plus positive at the top and negative at the bottom in the primary side. Okay. Now the transistor Q will be controlled by this pulse on off like that. When Q is on during this non-zero period, when Q is on, Q on is the short circuit like a switching element. Current will start flowing like this. Has been shown by this primary current, it will slowly go on increasing. Now you can see VQ, the voltage across the transistor will be negligible practically. Transistor is on, voltage across it is very small. That has been shown by ideally 0 here. Because of this short circuiting, current IP will start flowing in the anti-clockwise direction in the primary. Current will slowly increasing and primary winding will start storing that current. As when primary current is flowing, secondary current is 0 as per the convention of this transformer. And now output voltage we can draw later. Okay. Output voltage will be 0 here because actually the secondary current is not flowing. But for the timing will show it as not positive but will show it as a negative. The 0 output voltage because secondary current is no longer flowing will show it as a negative voltage minus. And flux is increasing, that is coupling to the secondary. Still it is not coupling to the secondary but it has that to couple. Flux is increasing because the current is increasing to this primary inductance coil. Flux is increasing, which will indicate that energy is storing in the primary inductance. Now let us see when Q is off during this next off period. The off period. So when this negative pulse Q off ಆಯಿತು ಅಂದ್ರೆ whatever the EDC you applied, it is appearing across this transistor Q. Already one store ಆಗಿತ್ತು inductance ಒಳಗೆ ಐತೆ. ಆಮೇಲೆ ಇದು EDC ಇದು also happen across Q because Q will be off. ಇದೊಂದು EDC. Now this EDC which has stored will reverse it. Q off ಆದ್ಮೇಲೆ ಇದು ರಿವರ್ಸ್ ಆಗುತ್ತೆ, ಪ್ಲಸ್ ಮೈನಸ್ ಇದ್ದು ಮೈನಸ್ ಪ್ಲಸ್ ಆಗ್ತದೆ, ಸರ್ಕಲ್ ಒಳಗೆ ತೋರಿಸೈತಲ್ಲ ಅದು. So this minus plus and this minus plus both will be added. You will be getting 2 EDC supply voltage appearing across Q. Are you understanding this one?
Yes, sir.
Okay. The small hash you are getting because of this inductance, primary inductance. Now after that it will start decreasing. Decrease ಎದಕ್ಕಾಗ್ತೈತಿ? Primary current flow ಆಗತ್ತಿಲ್ಲ, ಈಗ secondary current flow ಆಗತೈತಿ. Why secondary current is flowing? It is because primary current ಇಲ್ಲಿ ಏನು ಸ್ಟೋರ್ ಆಗಿತ್ತಲ್ಲ primary inductance ಒಳಗೆ, now that is started coupling to the secondary, that itself is flowing in the form of the secondary current. You can see secondary current will flowing from the maximum, means it has been stored, whatever that was stored in the inductance during Q1 start decreasing, start uh, decreasing through the load. Then it will become ಅದು ಎಲ್ಲಿ ಜೀರೋ ಆಗ್ತೈತಿ ಅದರೊಳಗಿಂದ ಒಂದು ಇ ಡಿ ಸಿ ಖಲಾಸ್ ಆಯ್ತು. ಈ ಪ್ರೈಮರಿ ಇಂಡೆಕ್ಸ್ ನೋಡ್ಸೋ ಒಂದು ಇ ಡಿ ಸಿ ಇರ್ತಲ್ಲ ಅದು ಜೀರೋ ಆಯ್ತು, ಜೀರೋ ಆಯ್ತಲ್ಲ ಇದು ಇ ಡಿ ಸಿ ಆಗ್ತೈತಿ. ಕ್ಯೂ ಆಫ್ ಐತೆ ಇನ್ನು ಇಲ್ಲಿ ಜೀರೋ ಔಟ್ಪುಟ್ ಕರೆಂಟ್, ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ವಿಲ್ ಬಿ ಜೀರೋ. ಇಲ್ಲಿ ಎರಡು ಜೀರೋ ಔಟ್ಪುಟ್ ಕರೆಂಟ್ ಇದೆ, ಜೀರೋ ಔಟ್ಪುಟ್ ವೋಲ್ಟೇಜು ಅದು. ವೋಲ್ಟೇಜ್ ಕರೆಂಟ್ ಎರಡು ಜೀರೋ ಇದ್ದಾಗ ಇಟ್ ವಿಲ್ ಬಿ ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್. ಆ್ಯಕ್ಚುಲಿ ಇಟ್ ಶುಡ್ ಇನ್ಕ್ರೀಸ್, ಇಲ್ಲಿಂದ ಬರಬೇಕಾಯ್ತು, ಇದು ಡಿಸ್ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಮತ್ತೆ ಆಮೇಲೆ ಇದು. Is it clear? That's what is known as a discontinuous isolated converter. So only when all the secondary voltage will become zero, no more secondary current is there, will be there, then the primary is zero. So avagide discontinuous ಆಗ್ತದೆ. Only when next Q will be on, primary current will start flowing, then this cycle will repeat. After this a discontinuous period, it's a discontinuous, ಇದೊಂದು ಪೀರಿಯಡ್ ಅದು ಪಾಸ್ ಆಗಿ ಮುಂದೆ ಕಂಟಿನ್ಯೂ ಆಗ್ತದೆ. Is it clear?
Yes, sir.
Any other doubts? Any other doubts? Out of 44, 3 members have asked the question. Special paper ಯಾರು ಇದ್ರಪ್ಪ? Only Sayed has asked. Raju Gowda yesterday has asked. Sachin Shapur has also interacted. What's all? Pooja Dudiki is there? Pooja Dudiki, roll number 103. Roll number 106, Prajwal Padshatti. Are you there? I have seen you have joined the class. Prajwal Padshatti. Prajwal Padshatti is there. Rohan Patil. Rohan Patil is not there. Sachin Kolkar. These people are continuously absent. Sachin Chapur is there. Sachin Chapur. Shantesh Babladi.
Yes, sir.
Shantesh Babladi.
Yes, sir.
You don't have any doubts?
Sir, yesterday I told.
Yesterday you told. What?
Sir, about choppers.
You asked. Okay. Other than that, you don't have any question. How you are preparing for the second CI? Varsha Banpatti is there?
Yes, sir.
You don't have any doubts? Are you reading regularly? Till now, whatever
sir,
the things you have covered.
Sir, up to model 2, I written the notes.
In model 2, you don't have any doubts?
Sir, could
Single
you
phase.
explain about freewheeling diode?
Yes. What?
Sir, freewheeling, the single phase half wave control rectifier. Effects of freewheeling diode, sir.
See, that is not there. Single phase full wave rectifier onward syllabus is there for your second CI. From that up to module 3 complete, you have to read. You have attended
sir.
first CI?
Huh, sir,
You not
attended, sir.
attended first? Huh?
Huh, sir?
You are not attended?
Attended, sir.
Okay, you got. You have to improve this time, second CI. So, ಇನ್ನು ಯಾವಾಗ ಓದೋರು ಮತ್ತೆ You're telling still you have to read. Yes, Rajagoda is there.
Yes, sir. Hello.
So only these people are present today. Rajagoda, Barsha, Shantesh, Sayer. So these four people are not there. Rachal Padshetty, Didigi, Ravan Patil, Sachin Kolkar, Sachin Chapur. So anybody want to ask anything? Any doubts? Any regular students? Let me take the attendance. Shall I wind up? 101.
Present, sir.